not, then you tekan Q1, tak boleh sebab kita ada timestamp. Dia kena reset balik dan baru boleh tekan. So untuk tu dia ada 30 saat timestamp. Tu ni logik dia yang apa kayak hold dia benda tu. Okay. And then okay, this is remote local punya logic. So basically sini pun temple jugalah, kita tahu sih banyak lah. And then this block is for measurement lah, where this is sync punya logic. You can see RSYN is sync block lah. Sync block is determined by, not determined, only these two will be affecting lah. Is that live need to be blocked or not? That bus need to block or not? So VTMCB3 triggerkan that live block. Running VTMCB3 triggerkan that bus block. Alright, and down here is actually phase voltage change to main voltage line. So biasa kita nampak kan value berapa tu, second single phase value, dia normal value jadi single phase value. This ni apa block ni ada pakai lah. So main voltage line akan keluarkan single phase value. Dan kalau UB prime ni adalah dia keluarkan value yang normal lah. So the conversion happen because of this UCVT. So this BMMXU actually more to not measurement punya value, tapi how the conversion to happen lah. Okay, YLTC kita tak pakai. Global is like general alarms lah. Or you can check all the VCU general alarms, ID fail. So this is more to internal logic lah. This one is the default logic gate of NR. And kalau yang nampak biru macam ni, memang biru ni kita tak boleh usir lah. Dia sudah lock maksudnya. Okay, and P2V is the under voltage trip punya logic. But you get your VTMCB trip and it will check for the under voltage punya trigger point. Okay, so user deposit tadi kita jumpa. Okay, sekarang goose memang ada dua yang actually you need to focus on two lah. One is out, another one is in. So apa beza in dengan out? Okay. Okay, so ini adalah goose out. Maksudnya dia signal yang keluar dari BCU ni. So apa signal yang keluar dari BCU ni adalah yes, Q not close, kita nak bagi dia keluar. So Q not manual close, kita nak bagi dia keluar. Live transfer in progress, kita nak bagi dia keluar. And then in progress pun kita nak bagi keluar tu. So these are the goose out yang kita determine lah. Kita determinekan lah yang mana kita nak keluar.
Maknanya dia bagi tahu yang keluar je lah kan.
Betul.
Dia bagi tahu yang keluar ke mana.
Tak ada
kan. Dia bagi tahu dia keluar tadi.
Dia keluar dari relay ni saja.
Okay.
So in case in future nak tambah goose out punya signal ke, you have to tambah dekat sini lah. So semua signal ni memang kita derive dari logic yang dalam dah sudah ada dalam ni lah. So dia ambil pulse timer, ni ambil dari apa, cut dia terus. Live transfer in progress pun kita ambil dari function out lah. So maksudnya dari logic ni memang kita sudah define live transfer progress tu apa. Where usually kita define live transfer progress dekat interlocking logic lah. You see here, kita dah define live transfer progress tu Q1 close, Q2 close, and gate jadi BLTIP. So BLTIP tu yang ada kat sini. So bila BLTIP tu high, goes out to trigger lah. Okay, then user goes in. So this is the goes in template. So you can see Ori punya template kita dah buat. If you notice, there's a lot of Ori template actually already set for us to put. In fact, it's like almost 44B. You can almost map to 44B for Ori. Yeah, other than that we have protection relay main to goes in and main one goes in. So Q15 goes in, Q16 bus coupler in service, bus section in service. Okay, so actually once you see this picture, you already can understand that goes in is already mapped at the BCU itself. So bila BCU lain yang keluarkan signal-signal ni, BCU ni kita boleh ada input signal yang kita boleh mapkan. Kalau input signal ni tak ada, then dia tak dapat receive lah dekat BCU ni. So your user goes in should be done lah if you are trying to receive the signal from another BCU. Is it clear what user goes in? Okay, together with user goes in, dia ada satu lagi page yang di mana into GGIO. Okay, what is into GGIO? Into GGIO is something like we define the MMS or goose to HMI. Okay, so where we can see the config user binary HMI, right? So let's say bus coupler, bus section in service. This is a goose signal, but HMI need to understand that this goose signal is being triggered at this BCU. So for that you need to come up with a specific block lah. Not all the signal is needed, but some signals like especially this kind of what they call it, this kind of MMS lah, sync fail or a live transfer in progress, because these kind of signals are triggered by the button that we press in the BCU, or triggered by some status. So where this, like, it's not a standalone signal. They are happening because of some other event or combination of few events lah. So when those kind of MMS, we need to create a certain logic for those MMS and give them a proper block lah, so that we can define them in HMI as well. Any question on this part? So here we define for bus coupler in service, bus section in service, Q15 open, Q16 open, live transfer in progress, B compartment stage 1, stage 2, ORIP and synchro check fail lah, together with Q15, Q16, Q25 status as well. Okay, so ORIP, this page basically just for ORIP lah. This is ORIP's into GGIO basically. So it's a huge page where it's just specifically made for ORIP. You can see all the 44 bays are mapped here, and it all comes to the one link which is called other bay ORIP. So to simulate this one signal, it will monitor all the BCU from other bays. Okay, so basically this is just into GGIO just for ORIP. Okay, so move on to mimic logic. Okay, so mimic logic will consist okay, mimic logic consists of the select button and it's basically interlock for the button lah. Okay, so it's mostly this is more to your bay control punya logic. So you controlling from the bay mode for that purpose. So during your bay mode there are certain interlock condition lah for the button to work. So that's the mimic logic over here. So which is the name itself is mimic logic because they are for mimic select buttons lah. Okay, then interlocking logic. So interlocking logic, you can see there are few sections over here labeled in the red color. So the first section is just for Q0 close and open, and then second one is Q1 open and close, third one is Q2 open and close, and lastly Q9 open close together with lifetime trade progress. Okay, so how does this interlock works or function? Okay, the most important place is this. This is, we call them as silo. Okay, silo is something like a result. If the silo is high, it means the interlock is pass. So in that way, everything over here, they need to reach this gate successfully. So for example, master trip operated shouldn't be there. So what we put for the master trip operated, we put a NOT gate. So when you put a NOT gate, when the master trip operated is not high, the AND gate will be getting it high, because NOT gate's purpose itself is invert the output. So if it's 0, the output will be 1. So over here, we try to use NOT gate for the signals that will be triggered, and some status we just use direct. Not some, I mean status we use direct lah, and station B we use direct. So let's say all are satisfied, then only the close interlock will be given lah. I mean the interlock will be passed. But let's say suddenly CBSF6 low stage 2 high, then the NOT gate will get 1, which will invert it to 0. So this AND gate won't be satisfied, and that will cause an interlock. So same applies to any signal that over here lah. Let's say Q1, let's say for maintenance, you want to do maintenance and you see Q1 open, Q2 open, but Q9 is closed. So automatically this AND gate won't be satisfied, and it will cause an interlock lah. So that's how the interlock works. That's how we do the mapping for interlock over here. So this is the result. Result is the place that you need to monitor lah. Yeah, apa tu? Oh, okay, sorry. So result is the place that you can monitor lah. Then you will understand the interlock easily. And over here also kita dah bagi ada label lah. Yang mana satu normal interlock, mana satu maintenance, open interlock, and then over here you can see on load transfer interlock and then normal interlocking. Then normal block function. Normal block function consists ORI, local, etc. like that lah. Okay, same goes to Q9, same goes to Q2. Any question? What interlock?
No question, tapi
Yeah.
Discussion
Discussion lah.
Bukan question lah. Comment. Bila every day baru
Okay.
kita buat ni kan, Kan every logic station ke apa tu, itu dia buat satu-satu ke? Ataupun ada cara yang lebih simple?
Cara yang lebih simple macam tadi saya tunjuk tu, kita pakai driver, select driver, macam tak buat VCU logic baru kan, VCU config baru lah. Cara yang
misi baru lah, misi baru oh extension lah. Okay.
So cara yang kalau simple, if you want to shorten the engineering method, yes, since you can use the DEV file as reference, so any DEV file yang project tu sudah ada, boleh je kita import dalam ni, then modify from there lah, according to the standard of that particular VCU. Kalau VCU tu sama lagi senang lah.
So,
but you need to know benda-benda yang perlu buat.
Ambil daripada B sebelah punya DEV, DEV B sebelah. Betul. B sebelah punya copy, then
you rename as your new bay.
Itulah cara.
Tapi LCD semua tukar.
Still kena modify sikit lah.
Betul.
Tapi tak ada daripada zero kan.
Memang tak ada zero. Kami
Zero kan. Zero saya rasa lagi susah sebenarnya.
Memang itu susah. If you're doing from zero, it's memang susah. So if you're using the files that have been used for project file, much more easier to modify from there lah. Because you can adapt and learn what's there already. Because yang project file tu kita sudah test and we know how it works, so it's more easier for us to learn it and modify it there rather than creating from scratch.
Daripada kosong maybe ada
Daripada kosong macam tak ada panduan langsung lah tu.
Kita terlepas sesuatu lah.
Betul. Any crucial thing can be terlepas, and it's very difficult in that way. Okay, so user page config, more to internal logic functions lah. Internal logic, master tree combine. Okay, here we choose the output point lah for master tree 1 and 2 and make it as 1 lah. Okay, so let it be master tree 1 or master tree 2, anything triggered, it will reset the master tree. So the 2 template will be always there lah, if in case you want to use or not use. Okay, for combine, combine is basically just a page where, let's say the signals are multiplied. Multiply means, let's say TCS have 2 TCS signals. We give them an OR gate and make it like 1. So either 1 high, also the TCS fail will high. So which will easy for us to map them into the LED page, so that the LED page will look neat and simplified lah. If not, there will be so much of signals over here and it will look very messy. So to avoid that, we create a page called combine, and we try to simplify it as much as we can lah. We try to categorize the signals. The switch gear local, we put all the switch gear in all the local signals in one OR gate, and we rename them as switch gear local. Similar for AC, DC, field, MC3. So this page basically just linking to LED page. Okay, and there's another thing over here which is this one lah.
Ini untuk keluarkan LED kan?
Betul. Ini untuk keluarkan LED, correct.
Kalau untuk yang keluarkan ke LDC apa semua tu?
Keluarkan ke LDC ya.
Kita nak keluar ke HMI apa lah. Contoh kita ambil CV spray and charge.
CV spring and charge. Okay, so as I said right, as long as dia macam binary input yang biasa, dia memang sudah ada MMS dia lah. For the particular signal, MMS tu akan high terus. Digital input, dia macam ada setiap satu input tu sudah ada MMS dia.
Itu macam yang ni, untuk CV spray and charge, kita tak boleh set time.
Apa dia punya input signal tu nak letak time? Boleh kan ada tempat tadi tu, which is
Sebab kan kita macam apa tadi sendiri ya. Terus mereka ada alam keluar.
Sekali macam mana? Again?
You close dia mereka alam keluar.
Okay. Tapi
kan
dia
macam,
for a while only lah, dia lepas tu normalize terus.
Sebab tu dia akan normal. Sebab tu yang sistem yang lama dia kena timing. Contoh dalam 2 second, 3 second. Dia ikut equipmentnya ni lah. Dia ada timer kan. Tapi sekarang kita dah timer tu tak ada. Dia tersap kan.
Yalah.
Kita nak ikhlaskan benda-benda.
Demo tu mesti setting punya part lah.
But
that one, before we apply at site, kita kena buat account office dulu lah. Such a new implementation not recommended to apply terus kat site, because this one related to setting. So we need to make sure the setting is compatible first lah, whether it works or not, and then once it works, then we can apply at site. But I think mostly should be here lah, the time for it to adjust. Okay, this is another interlock page for especially just for execute in progress button lah. So you can see all the mimic select here, right? They have a reset logic for execute in progress. So there are few blocking that you need to concern other than just interlocking logic itself. So to operate a button from B, you have to make sure there's not a repetition selection lah on without a successful operation when you want to operate a isolator or breaker. Alright. So there are 3 criteria that you need to consider, 3 or 4 criteria. Which is one is just now you see the in progress, and then selection button, mimic select. You need to wait until they reset the timer for you to press the button. If there's a failure, if the operation is not successful. And another one is the mimic logic. So you need to consider about mimic logic as well lah. This is totally on operating from B. So other tools are operating from HMI and SCADA gateway, but this mimic logic basically solely just for operating from B lah. Okay, and yeah, so that's basically most about the VCU mapping and logic. And you can see over here, this is the output card point lah. So mostly over here you can see to do breaker open, this is the point that it uses. Breaker close, this is the point. Card 15, point number 2. Same goes to Q1, Q2, Q right. And last kali close command permissive and open command permissive. Manakala card kedua pula, dia ada under voltage trigger point, general alarm mostly for the connected to the initiator lah, and then reset master trip. Card 16 betul. Dan ada SIM juga lah. Basically this one will be used for 275 gig. Okay, and almost all VCU have the arrangement of same blocks lah over here at their own. Okay, so just like you asked a question, right, where if you have an extension PCU, what are the main things that you want to concern about changing? Okay, so I will tell you. Okay, first of all, you need to ensure what typical is that. Bus coupler, bus section, OHL, UGC, OTX, OSGT. Okay, once you ensure the typical, then you already got the DEV file. First thing you need to check is signals. You compare the signals with
Ini bebas apa?
yang mana?
Ini buka ni bebas apa?
Yeah, just showing example lah. Okay, so you compare with section D lah, conceptual. And once done with BI signal, most probably you need to check it interlocking logic. Okay. So if the interlocking logic also following the conceptual, then lastly you need to check on COM settings. Okay, you need to change the COM settings for your application. So basically these three places is the most places that you will check lah, if there's an additional RBC. Others all you will be following the same. There won't be any much changes for you to apply. Unless no, it's not unless lah. Unless you want to troubleshoot lah. Unless it's a wrong backup or what, something like that. But if it's already a good backup, they're already working and commissioned, there shouldn't be any issue lah. So these three places you need to check. One is PI signal, or sorry, LCD graph as well. So LCD graph you need to make sure the device number lah. You will follow according to GSO standards, right? Then after that, interlocking logic, then last kali COM settings.
Logik ni. Ni kita semua compare dengan conceptual lah.
Betul. Bahan-bahan ni kita compare dengan conceptual. Sebab whatever PI signal yang you ubah, as long as you tahu say benda ni yang depan ni, if status if there's changes in status, then yes, there's a huge work lah. It's not simple because when you do something changes in the status, then you are considered changing user depots. But if as long as it's just some changes on BI signal at below, you shouldn't have any much problem lah. But then try to ensure the arrangement of the signals same. If you are copying another bay, and then try to make the signals follow the same BI numbers, cut numbers in the drawing lah. I mean, future whoever doing the drawing, let's say it's a new bay and new vendor is doing the drawing, if possible try to follow the similar base signal positions lah. Or position or the signal follow the product app also is good enough, because when you try to do some changes, you won't have major changes to troubleshoot as long as you follow the previous pattern. So if there is suddenly some changes over here, let's say you bring Q1 local and upstairs, then you need to check all the pages that have Q1 in local, whether it's already changed or replaced. Because kalau you dah ubah benda ni ke sini and then you jadikan dia spare, semua Q0 local yang ada dalam page yang kita buat pakai untuk linking ke apa ke, dia akan jadi spare juga.
Spare.
So itu kena pastikan sudah berubah lah. Kita dah replace benda tu. So itu yang jadi careless mistake nanti.
Oh.
Kalau kita terlupa ke, kalau termiss ke, then we don't know what have been changed. So that's why kita tak try ubah banyak. Kita try to maintain yang mana boleh maintain, and then try to follow it lah. Then easy for the troubleshoot. Because we have a BCU yang 100% working properly, already commissioned, already tested, and then you are replicating another one. So as long as you follow the most of the things same, you will find it easier to troubleshoot lah. Because it should work as similar as the live BCU supposedly.
Dia kalau kita beli lah kan, contoh new issue lah kan,
Okay.
baru lah,
Okay.
baru lah. Default setting IP dia berapa? Ke dia dah
Front board always 100.
ada. So
Maintenance
kita,
IP.
so kita upload new setting from there lah.
Yeah, correct.
Tapi apa macam untuk current diff dia punya tak pakai 100 orang dia punya IP address?
Betul. Current diff is a bit different lah. Dia akan pakai IP yang dia ada satu default IP. Biasa depan tu boleh nampak lah bila kita dah download. Then once you download setting baru, dia sudah ada IP baru kan, dia akan stick to that IP baru.
Oh.
So biasanya current diff IP belakang dia dengan IP depan dia sama. Only for current diff lah. CBM dia tak follow macam tu. Oh ada rayo ke Frio ke, all maintenance IP is 100 kecuali current diff.
Satu lagi macam BI signal ni kan, kalau kita ada point spare yang kita nak pakai, kan kita kena tengok juga dengan apa product app kan.
Betul.
Tapi kalau macam untuk boost out ni kan ada yang spare kan, perlu kita tengok dekat product app juga ke ataupun spare tu dah memang spare?
So far untuk goose out tu dia tak, product app tak mention pasal MMSD lah. Apa tu nama variable dia lah. So far dia tak mention. Tak mention sangat lah. Because I notice here I notice here go for boost control block. Okay, so on apa tu yang signal yang sudah ada tu dia memang sudah ada dia punya variable nama lah. But they never mention anything about spare over here.
Oh.
So on spare part it's on your on plan lah how you want to use.
Okay.
But recommended whenever there's a goose changes that you want to do, it's recommended to test that maybe separately and somewhere before you implement that goose at live. So the testing should be done properly, like because goose involve quality as well. So you need to ensure the quality works properly. And if the quality doesn't work, the goose may not receive to the particular point that we are sending. Or we are receiving also, it's the same process. The quality must be maintained. So what I mean by the quality is properties of goose. So goose have several properties lah, where the MAC address need to be correct, app ID need to be correct, GOCB name need to be correct.
Itu yang dikatakan quality dia tu.
Betul. So these are the things that will affect the quality lah. So yang ni semua kena make sure all correct, then shouldn't be any issue lah. So that's why I say if you want to test, if you are implementing a new goose signal, then it's recommended to test it first. If it's a new one, but if it's a one already with any use, then you can confidently implement it lah. But still recommended to test first lah before implemented at site, implemented live lah, what I mean. Okay, any question on VCU? So just to make it short, for PCS 921 or 931, it doesn't have this a lot of modification. They are very straightforward actually. So let's say I try to open CBN. Okay, you can see even they have device config, signal setup, similar as BCU, but it's user defined. So it means you cannot modify anything over here. And they don't have a certain property called all map on. So they have few pages only. They have goose input, goose output, and few protection logics. So all these logics are in blue color, and all the goose input output are in blue color. So when it's blue, they are locked down. We cannot modify anything. Only the tip product can modify if they want to modify lah. So only BCU we are allowed to have some modification over there and change according in future, but other relays mostly stick to the setting or logic that given standard lah. So there's no much thing to change over here. So in future, if there's another CBM is being added, most probably you can use the same DEV and then you just need to change the setting. COM setting only. Okay. So whatever the, model that use 9705, we can modify in lot ways lah. For example, RRIU, FreeU, the HRIU, they are mostly like VCU. So other than 9705, which use 921, 931 or 915, there won't be much changes can be done for that release lah. Because protection release, they lock the particular logics and they want to maintain the standard.
Okay, DV file yang untuk BCU ni kita boleh pakai untuk 275 lah, jadi tapi perubahan dia sikit lah kan.
Betul. Dia beban dan dia akan corrupt juga lah end of the day. Because when you use the DEV file from 9705, dia okay, satu BCU tu dia punya functionality CPU dia start from the ordering code. Okay, I show you lah. Okay, actually good question lah. So dekat device setup ni, you can see there's a function called MOT. If you notice, the MOT is actually ordering code of the particular relay. So origin of the particular IED is start from the ordering code. So this ordering code is what determine what kind of CPU is being used.
Okay.
Clear? So when this particular relay use this particular CPU, and you are trying to use PCS 9705, which will cause incompatible lah.
Tak boleh ke?
So automatically the relay won't will try to flush out that particular DV. So you won't be able to use unless you make a huge version changes in 9705, make the model change, then supposedly you can use lah, but it's a very unnecessary process to do. And then it's also, we cannot be doing that lah. It will be done. Even that modification can be done by, I think supposedly NARI only now. Okay, anything? Yeah. Okay guys, so we take a 10 minutes of break. Okay, by 4 can come in. So we continue with SCL configurator a bit. Then guys, is okay, we finish at 4:30. So okay.
Okay, Jerman.
Itulah okay lah.
Tak boleh buat apa.
First day juga kan, so 4:30 this lah.
Di sini.
So by 4 come back, can eat inside no problem. Then we continue half an hour on the serial configurator.
Yeah.
Okay, right.